Okay, this video is looking at section Stsd F, and it's the second video for this section. We're continuing to look at the normal distribution. Now, normal distributions are symmetric about the mean, and you can see that with this curve here. This is my normal distribution, this curve, and you can tell from that, if I delete all this, that this side of the curve is equal to this side. So it's symmetrical about the mean, where our mean is this centre point here. Okay? Normal distributions are often described as bell-shaped. Data collected on heights, weights, reading abilities, memory, IQ scores are often approximated by normal distributions. Now, we were just talking about standard scores or z-scores. That leads to what we call a standard normal distribution. Now, the distribution of z-scores is described by the standard normal curve. Now, we remember that the standard normal curve has a mean of 0 and a standard deviation of 1. Now, we would normally be talking about populations, so mean of 0, standard deviation of 1. Okay? So now let's look at standard normal distribution and probability. For normally distributed data, 50% of the data is below the mean and 50% of the data is above the mean, and that's because it's symmetrical. So you can see that from this picture here. In a normal distribution, the distance between the mean and a given z-score corresponds to a proportion of the total area under the curve. So what I mean by that is that this area under this side of the curve adds up to 50%. The total area under a normal distribution curve is taken to equal to 1 or 1%. So if I add the other side, which is 50%, I get 100%. The values of the proportions written as decimals for the various z-scores are provided, should be a D on the end there, in a statistical table. And that's the normal distribution areas. And that's in the appendix in your textbook. So let's look at calculating proportions. Now, the value in the normal distribution areas table that's provided in the appendix of the textbook give a proportion value for the area between the mean and the raw score greater than the mean, converted to a positive z-score. So that's represented by this area here, where this z is my z-score. So that's what the table does. This is the mean here. It'll give you the area between the mean and the positive z-score. Now, remembering that our curves are symmetrical, so if I have negative z here, that's going to be exactly the same proportion as positive z because it's symmetrical. So that means area A equals area B, or proportion A equals proportion B. So as values of z for the same that are the same distance from the mean, they correspond to the same proportion. So z is 1.2, z is negative 1.2. The proportion is going to be the same. It's just that one's below the mean and one's above the mean. Now, in a normal distribution table, 68% of values lie within one standard deviation of the mean. So here we have one standard deviation above and below the mean. Okay, so this percentage is 68%. That's standard, it's given. So 68% lie within one standard deviation of the mean. Okay, next, 95% lie within two standard deviations of the mean. So if I come out to here, this whole area here is going to be 95%. Now, another thing you should note is because we have a symmetrical distribution, that I know that from here to here is 47.5%, half of 95, and from here to here is 47.5%. So with 3 standard deviations above and below the mean, you can see that it's nearly the entire curve. Okay, although we can have 4 standard deviations above or below the mean, 99% of scores lie within 3 standard deviations, which is nearly everything. Now, I've just extracted the normal distribution table here, so it's going to be harder to see, but just for aiding you and seeing what it's talking about. Say I have a z-score of 1.25. What I do is I go all the way down this side to the 1.2, and then I go across to 0.05, which is here. So this value here is 0.3944 or 39.44%. So what that means, if this is 1.25, this area here is 39.44%. So let's look at some examples. Use the normal distribution areas table to determine the proportions that correspond to the following z-scores. And I have extracted a part of the table so I can aid in explaining it. So z is 2. So I just go down to 2, and there's no other decimal points, so my proportion is straight off 0.4772 or 47.72%. For 2.1, I go down to my 2 and I go across to 0.01. So it's 0.4778 or 47.78%. Okay, so for 2.1, we go down to 2.1. Again, there's no decimals after the 1, so it's 0.4821 or 48.21%. Next, 2.13. So we go down to the 2.1, we need to go across to the 0.03. So that's 0.4834 or 48.34%. Pause the video, give some a go yourself. Okay, 0.12. So I go down to 0.1 and I go across to the 2. So that's 0.0478 or 4.78%. Negative 2.3, well, that's going to be the same as 2.3, just below the mean. So I go down to 2.3. I don't need to go across any more than just the 0 because there's no decimal places. So that's equivalent to 48.9. Sorry, I should put the decimal first. 0.4893 or 48.93%. Last, negative 0.281, so that's going to be equivalent to 2.81. So I go down to 2.8, go across to the 1, so I get 0.4975 or 49.75%. Okay, so I hope that makes sense. Okay, now finding z-scores from the normal distributions table. So now we've just found area, how do we find the z-scores? Now it's possible to find a z-score for a required proportion from the normal distribution areas table. We're just going to go backwards. So first of all, you need to find the proportion in the middle of the table and then read back to the row and column headings to determine the z-score. So what do I mean by that? If we look at my two examples, so 35.54%, which is the same as 0.3554. We look in the middle of the table, and note that I've only extracted a portion, which so you can't see everything. But if you can find 3554 in here, and you can see it right there. So I go back to my column and up to my row heading. So that means my z-score is 1.06. Next, 42.8%. Get rid of this. So that's equivalent to 0.428. So again, I look in here, 0.428. Now I've got 0.4279 and 0.4292. So I can say it's approximately here, or I could say it's in between the two. we're not going to get that pedantic with it. So if we come back 1.4 up to 1.06, we'd have to put Z is approximately 1.46. Some of you may want to answer 1.465, so in between these two, that's also okay. Now note another thing, that our z-scores could also be the negative of these and still have that same proportion. I'm just assuming that we're looking at above the mean. This is the end of this video, but there are no exercises that correspond to it, so you need to move on to the next video, Stsd F Part 3.